Hi there, my name's Nick and I'm a Senior Solutions Engineer here at Treble Technologies. And today I'll be going over two new plugins we've released, one for Rhino and for Revit, and I'll be showing a little bit about how these plugins work and how you can get your geometries from either tool into Treble seamlessly. First, let's start with our Rhino plugin. So this has a very similar functionality to what our already released SketchUp plugin does, but now we've also integrated it into the Rhino ecosystem as well. So to install the Treble plugin, all we need to do is launch the packet manager within Rhino and simply search for Treble. Once you've installed the plugin, then you can launch the plugin by typing Treble in the command window. For users that have used our SketchUp plugin before, you'll notice a very similar user interface. And what we can do now is check our geometry, but also fetch geometries directly from Treble as well. So once I've installed the plugin and I've created my geometry, which I've done here, you can see that I've made a fairly simple performance hall, and I've also assigned all my different layers here as well. I can launch the Treble plugin. Simply by just typing Treble in the command window, the plugin is now launched, and we'll notice the first thing it's asking us to do is to set up layers. So once I click that, what is required is for us to move whatever geometry that we want to be imported into Treble's default folder hierarchy, or Treble's default layer hierarchy. What that essentially means is that only the layers that are within the hierarchy will be imported into Treble. Now this can be useful because it's common to also import additional geometry or even PDF drawings within Rhino to help make the model creation a little bit easier. So instead of needing to delete these items from the model itself, we can simply just drag what we need directly into our Treble folder. So now that's been done, we can now check the geometry. Now this checking process is analyzing the model, and it's looking for if the model is watertight, and it's also looking for areas where some additional feedback or efficiencies can be made. We can see that this geometry is passed without any further updates or suggestions needed, and it's ready to be uploaded. The other functionality with our Rhino plugin is that it supports a two-way communication stream. So not only can it send models to Treble, it can also fetch them back again. So for example, if I click the fetch feature now, all my projects that have been uploaded to Treble, I can now fetch the geometries back. So for example, this auditorium, it'll ask me if I want to replace what's in my existing Treble geometry. So I'll say yes. Okay, and now I've fetched my, my auditorium here, and I can start to edit that as well. One of the useful features about our Rhino plugin is that it can fetch models from Treble that didn't originate from Rhino. So for example, if you or a colleague created a model in SketchUp, uploaded it to Treble, it can still be fetched via the Rhino plugin as well. So for example, this auditorium that we see here was also created in SketchUp and now been fetched into Rhino. This is great for being able to support a number of different workflows, particularly if teams have diverse ways of working and using a series of different CAD tools as well. What we will notice, however, is that these models have come in as meshes, and they can be a little trickier to work with. So what we would normally recommend is to select the model and then to change your mesh into a NURBS geometry. And we can do that in the command prompt with the mesh to NURB command. So just like before, we can now check our geometry to see if there's any feedback being provided by the plugin. What we can see here is that there are some notifications that we're being given. Primarily, we've got some short edges detected and some small gaps as well. And what this refers to is very small geometric detail within the model. And this can have an effect primarily on the simulation time when doing wave simulations. So if we highlight the plugin, we can also zoom in on some of where these areas are, and that can help us simplify and refine the model. Now, it should be noted that these are just recommendations. You don't have to make these sort of changes, but if you are experiencing longer simulation times, then the single most efficient thing that you can do to improve your simulation time in a wave simulation is to simplify the geometry. So if we're happy with our edits that we've made within the Rhino plugin, we can then upload the geometry like before. It's also worth noting that we'll be leveraging the Rhino plugin in the future to make leak detection easier and to also help make approximate watertight shells of models as well. So stay tuned for some of these future updates to come.